Alright, today we're talking about firewalls and different network security appliances. We're going to do a little bit of a comparison of some of the Cisco ways of doing things as to how Juniper does it in terms of licensing and measurements of those devices. And we'll just get a basic overview of how the ASA firewalls work, and we'll take a look at how we can set them up in Packet Tracer as well. So, to get started, we're going to quick take a trip back to what we've learned about firewalls in the past. And we should know what we have with stateful and stateless firewalls. So a big topic here is that when we're looking at purchasing a firewall, or when we're evaluating those between different vendors, we need to look at how they're actually processing those packets and what kind of information that they're keeping track of. When we have a stateful firewall, the firewall is going to keep track of the entire TCP connection state. So after we've gone through that three-way handshake, the firewall goes through a few different processes to figure out, can it route the traffic? Is it allowed by the firewall? Do we have any application layer processing on those packets? And it keeps track of that stuff. So as throughout the duration of that TCP session, we don't have to continually be rechecking every single packet coming through. Now on the converse side of things, we have stateless firewalls. Stateless firewalls are much more simple in the fact that they just look at every single packet processing through that firewall and figure out between the source and destination if they should allow it. Now there's really no way that you can say one firewall is always better than the other because there's certain situations and things like budgets that influence your choice on purchasing one of those firewalls. So you kind of have to evaluate those and know a little bit about what you're looking for to see what you have coming forward. So on the Cisco side of the fence, the stateful firewalls are now the ASA appliances, or the Adaptive Security Appliance. They are following the PIX firewalls. So PIX is a little bit outdated, and we are starting to see those pretty rarely. So those are the little bit older models of firewalls. But the cool thing about these firewall appliances is that we see them being built in with VPN capabilities. They have intrusion detection and intrusion prevention modules. They do layer 7 or application-based filtering, and all sorts of other cool features baked into them. Now the reason we might want to have an actual firewall appliance as compared to what we had with the routers doing firewall rules in the iOS is that the actual ASA firewalls will process this stuff a lot more quickly. Also, the metrics that the vendors give us based on how many packets of throughput they can have and what establishing a VPN connection does to your allotted bandwidth really starts to make a little bit of a difference when we make those choices. They're still good in different areas. You just kind of have to know when to choose each one of those. For example, your firewall appliances will more than likely sit on the edge of your network, whereas your router-based firewalls might be in a little bit less traffic or a little bit less priority areas. We're just going to do some simple rules, maybe blocking a couple VLANs from talking to each other or different subnets that we don't want to have actually communicating back and forth. So on the topic of where we actually figure out where to start putting these firewalls, we also got to think about how we're going to use that firewall. Now there's two kind of main models that come to mind here. We have internet access and internet present. In an internet access model, the firewall is going to sit between your internal trusted clients and the external outside resources that you might not trust as much. Oftentimes, the internet access firewalls are configured to block incoming traffic to your network, but yet allow your clients to get out and reach those resources. It's called a egress filter set when we talk about those rules of the firewall rules leaving your network or allowing traffic to leave your network are the egress firewall rules. The opposite side coming in would be your ingress firewall rules. So we need to establish internet access for our users, but sometimes if we're a business, we might actually need to establish a presence as well. And basically what that means is we're hosting a service that we want external people to access. We have to make sure that's in a separate, segmented, and secure network for those clients. So oftentimes we see the addition of a DMZ onto our networks, and that's where we can place those web servers or whatever resources that we need to have out online. The ASAs that we primarily deal with here on campus are the 5505s. So they are little 8-port, they call them telecommuter firewalls or small business type firewalls. We also have 5520s, which are a lot bigger. We could actually run very large institutions off of it. in conjunction with some other devices too. But at the end of the day, it doesn't really matter how much these firewalls have for horsepower. When we're learning about them, we need to learn how to configure things like the IPS and IDS modules. We need to learn how to configure VPNs and just basic firewall filter sets. So that's kind of our primary focus is we need to know there's different models, different things are going to perform better than others, but we want to really understand as well how to configure these devices. And you can see a chart here from Cisco of kind of the scale of firewalls that we're dealing with. As I said, the 5505s they call the teleworker firewalls. Those are kind of at the bottom of the chain as far as how many connections per second are they allowing, and also, what is their max throughput and max VPN sessions, things like that. Whereas those 5520s are just a couple steps up, but you can see they have a lot more bandwidth that they can pump through, and they also allow for 3 times as many connections per second. Now, the crazy thing to think about that is even as fast as those devices are, they're still pretty well down in the tier of how big firewalls are really getting. These are for very, very large customers. When you see like the ASA 5585, those are giant firewalls. We talked about some of the firewalling that we can do with the iOS on routers, and we can kind of see the similar connections that they're making there. So we talk about speed in terms of megabits per second. A little bit different measurement they give you on this one is simultaneous rich media collaboration sessions. What that means to me is usually how many conference calls or video chats can you be having simultaneously. So we can kind of skip over this and get to the more interesting measurements of our firewalls. And let's take a look at the charts of really what we start to get into as system administrators here. Now we get some very interesting measurements here, and it's kind of helping us figure out what firewall would we need and how big of one, how much bandwidth do we need, or how many connections do we need to support. So at the 5505, you can see that we have 4,000 simultaneous connections per second that we can handle at once. PPS rate, or packets per second, it can process 85,000 packets per second. In total, depending on our licensing, this is what the slash means between those two numbers. If you have the base license, you can handle 10,000 simultaneous connections. If you have the Security Plus license, you're up to 25,000 simultaneous connections. Now this is good to know because if you think about how many connections your computer just sitting on your desk is making, those numbers can get eaten up pretty quickly. If you have like Netflix or Spotify streaming, you might have a few browser tabs open. Sometime just for an interesting measure, run netstat on your machine and figure out how many TCP connections your single computer is making out to the internet at a given point in time. When you extrapolate that out over a business that might have 100 or maybe even 1,000 users, you really start to need to pay attention to the connections per second that firewall can handle. I always think it's interesting too to see how much bandwidth do these things support here. So we have a throughput of 150 megabits per second. But look what happens as soon as you turn on the intrusion protection system. That cuts your bandwidth in half. Right? So if you actually needed to push 150 megabits of traffic through and you also wanted the IPS, you would need to move over to a 5510, which can handle 300 megabits per second with IPS on. Now we kind of look at the other interesting things you're going to do with a firewall. You're going to do site-to-site VPNs or remote access VPNs. So site-to-site would be a scenario where we would want to bridge 2 LANs together over the cross of the internet and treat them as if they're on the same local network. Remote access or the RA VPN sessions would be like your telecommuters, right? So people establishing a VPN connection back to your office so they can work securely and access your internal resources. In any case, what I'm trying to get at here is there's a lot of different measurements, and we really need to want to, figure out what do we want this firewall to do, and then make sure we're choosing them to match that appropriately. Juniper does the exact same thing. So we can see the SRX 300 series up here is about the equivalent of the 5505. It's a little bit newer, so a better comparison would probably be Cisco's ASA 5506, just the successor to the 5505 model. but they show you kind of the same style of measurements here. So this is a somewhat industry standard thing that people are going to show you. So we have, if we have the IPS on, how many megabits per second can we handle? It's about 200. We have an IPsec VPN, right, with the iMix, which we'll talk about here in a minute. That's the internet mixed traffic. It simulates kind of just normal use. So they've modeled packet sizes for average users and kind of figured out what normal internet traffic looks like. But those same style of measurements are here. We had our connections per second and things like that. So moving on here a little bit, let's actually talk about connections per second a little bit closer. When we talk connections per second, we're talking specifically a stateful firewall, the firewall that keeps track of the TCP sessions. What we get at is the idea that more gigabits per second of throughput is not always better. In a very extreme case, think about if you had a firewall that could only handle 10 connections per second and you had a 10 gigabit pipe going into it. Would that be better than a firewall that has a gigabit pipe going into it but can support 1,000 simultaneous connections per second? It's kind of an either or. You really need to look at what the network is actually requiring of. But the reason that this is a very important measurement for stateful firewalls is because of the idea that they use conditional forwarding. Now, when a packet enters the firewall coming in from the outside interface, the very first thing the firewall does is it checks, do I already have a connection established? If the firewall already has a connection established, there's no point in going through the whole decision process again. We've already allowed or rejected that firewall rule. If there's not one, we start going down the path this way. So number one, we establish the TCP connection. We go through that three-way handshake and make a connection there. Step two, is there actually a route to the destination? So even if this traffic is allowed by the firewall, if it can't actually send it or transmit that packet to the destination, it's going to drop the traffic. Next thing we check is our ACL rules. These are kind of those traditional firewall rules. We're permitting and denying resources to source and destination IPs, looking at the packets and ports and what is actually going through those. If it's allowed, we check for address translation, which is NAT. So typically we're going to be translating from the outside IP address we have to an inside host. So that's one of our IPv4 problems that we have. Fifth thing, if we have it turned on and if it's enabled, we can actually do application inspection rules. You might have heard of application inspection as layer 7 or next gen firewall filters. Basically what it is it's another layer of security. So instead of saying, I'm permitting all HTTP traffic or HTTPS traffic from a source to a destination, you can actually start to inspect what that HTTPS traffic is. Maybe I want to allow all normal web browsing traffic, but say something like Facebook Messenger, which probably runs on HTTPS, we want to block that. So we can actually start to get a little bit more fine-grained in specifically what applications are allowed and denied. Moving down the list, it actually performs NAT translation. If we have the IPS module installed, which is usually another license or even sometimes a piece of hardware that we need to install, it will go through that, look for any malware or malicious files coming across it, and then we send it back down onto our layer 2 portion of our network. So there's a lot going on when a packet hits a firewall, and this is where our connections per second metric really tells us what can that firewall actually handle? How long does it take for that stuff to get through? Another common measurement you'll see is packets per second, and basically what that is just how many raw packets can the firewall process every single second. Now when you think about this, if you think about a three-way handshake, we have the SYN packet, an ACK packet, and the SYN-ACK packet, and then the sending host can start to transmit data. So at a very minimum with TCP, it'll take 4 packets for the sender to get 1 real packet of data across. That's still only 1 connection. So those measurements we can see are a little bit different. It's 4 packets that represent 1 connection. And that's how connections per second is a little bit different than packets per second. Now when we look at packets per second, we can kind of do some math here and figure out how many packets per second equates for how much gigabits worth of traffic we might need. So this is what we are talking about a little bit before when I said that word iMix or internet mix. Basically what iMix is it's a profile that's based on statistical sampling done of just various internet routers. And all of those people that did the sampling published the layers of granularity, such as simple and complete layers, in an RFC. And they said, this is what our normal internet traffic looks like. How about you guys? And what we ended up with is across all of these different routers, all the people that did the sampling on those routers, is we figured out what typical usage of internet traffic looks like. Now, firewall vendors try to relate to this because it's the only real measurement that we can really make and say, this firewall should perform well in a network that handles this much traffic if it follows the general iMix spread. So what I'm getting at here is that if you have a network that ran 100% of their clients were streaming Netflix movies versus 100% of their clients that were on something like Slack or some sort of messaging application, we might have the same number of connections being made, but the actual bandwidth is going to be different. Now we know that's unrealistic that 100% of our users would be using Slack or Netflix, so we have to kind of break it down and say, like, over typical applications, this is kind of what our distribution of packets looks like. So I pulled this chart from Wikipedia, and they said a typical iMix spread, 58% of your packets going across the network will be 40 bytes in size, including the packet header. 33% of the traffic on a normal given network will represent 576 byte packets. And last but not least, 8% of the traffic going across a typical internet router will be 1500 bytes, including the header. That gives us a general idea of we're sending a lot of little packets. Are they big packets? What does that spread look like? And this helps us figure out really, how much bandwidth on that interface we might need. I can go back and you can kind of read through the calculation of packets per second, how much that actually equates to gigabits per second. But basically what they do is they take an average of the packet sizes and how many of those packets represented that number. So they figure out your average packet size in bits for all these measurements, and then just divide that out into a gigabit interface. Another interesting measurement is the simultaneous connections. So how many concurrent connections can you have? Basically, if we kind of broke this down into a calculation, let's say you had 1 million concurrent connections that you wanted to make, and your firewall had a rate of 50,000 connections per second. Basically, we can figure out how fast we can connect these million connections that we want to establish. So if I had my million connections is what I wanted to make, I can do 50,000 every second. Comes out to be about 20,000 seconds it would take us to establish all those connections. Just different interesting ways to measure the throughput and performance of these firewalls. Now before too long, we're actually going to get into Packet Tracer and start looking at the 5505 appliances. But they look like basic little kind of router firewall combos. On the 5505s, you get 8 ports. They can operate in layer 2 or layer 3 mode, which is a little bit of a different way than they're doing things now. Most firewalls now are supporting only layer 3 mode. If you want to do layer 2 security, they tell you to buy a managed switch. So some of the kind of base characteristics with it, if you have the base license, you get 3 VLANs without trunking. I think you can have 10 internal users. You're just a little bit limited by the license. The bigger 5520s that I had mentioned before don't look a whole lot different. They have a little bit more bandwidth. You can see they actually have a hardware-based IPS module on the left-hand side there. And they have fewer ports, but those should be running as layer 3 ports, not layer 2 ports on these models. I think the idea with the 5505s was that if we can make a box that can support a small business, kind of that firewall switch combo all in one, that might be a more appealing market edge, but of course they've since changed that to be all layer 3 again. On the Juniper side of the fence, the SRX 220s, which we'll work with quite a bit as well, look almost identical. So these have 8 ports on those. I believe they're all the same kind of thing, 100 meg ports. These might actually be, on the 220s they are gigabit ports. The ASA is 100 meg ports. But end of the day, same functionality is all there, just a small, medium business type firewall. So when you walk through the ASA configuration, almost all of what you've already studied is going to be there as well. So navigating the command line, it's called the ASA instead of the iOS, but the commands are really the same. You have a privileged mode, you've got config mode, question marks for help, tab completion. That is all still there. When we boot up the sequence, you're going to see that the model number, of course, is different. And then the actual binary file, the image that this runs for software, will be an ASA image instead of the iOS images. Other interesting things to take a look at when you do a boot sequence is look at what license is installed on that firewall. This firewall has a 5505 Security Plus license, which is the little bit larger license, and I'll kind of show you the breakdown of that here on the next slide. So Cisco and Juniper do their licensing a little bit different on firewalls, and it's something that you really should talk to a reseller about to fully understand that you're getting what you're paying for and that you have the appropriate licenses for what your business is asking. So on Cisco, basically what you oftentimes get is a stripped down version of the firewall. So the base license you can see here, this is just a snippet of some of the features. You can only have 10 concurrent users on that firewall at a certain time. With the Security Plus, we can actually get up to 50, or rather unlimited users as far as your optional licenses go. Now when I say we only can have 10 devices behind that firewall, that means 10 hosts using an IP address on the internal side of that firewall can be connected at once. I ran into this problem when I was consulting for a cell phone company. Basically, they had opened a new store, hired another person, and intermittently, when someone would come back from lunch, a random person around the office would lose connection. What happened to happen is we had the new hire was the 11th person in that office. So because of this limitation of only having 10 people that can be allowed to use the resources at once, when the new person would come back or someone else would return from lunch, the firewall would drop somebody else's session. So they needed to purchase an unlimited license. You see other kind of interesting things here as well. The firewall, the hardware doesn't change at all. But with the base license, you have 10 VPN connections. Security Plus, you get up to 25. No changes in hardware, just a change in license. You'll see that same kind of thing here with the VLANs down at the bottom. You go from 3 to 20. Basically, just like I said, you're getting a stripped down version. You pay to unlock all of the features. The Juniper side of the house does things similar, but still slightly different. Typically what you get is you get the base firewall that's totally unlocked, so you don't have like the limitation of how many users and things like that, but they sell you the additional modules at an extra cost. So if you wanted application layer inspection, where that maybe is included on an ASA, you'd have to pay for it to unlock that module. Same with their threat defense and intelligence. That's basically their IPS versions on the Juniper firewalls. So these three things I have here, the advanced routing, application security services, and threat defense, those are all add-ons to that base unlocked firewall. Really, licensing and networking equipment gets confusing, but like I said, any vendor, any reseller will be happy to talk licensing, and they can usually break it down very, very well to make sure that you're not paying for things you don't need, but it's also going to perform for what you want it to do. So kind of flipping through some of the commands, we can actually just jump into one of the firewalls on this and go through a little bit of the configuration on it. So we'll flip over to Packet Tracer and pull up a ASA. So down here in the very bottom left-hand side, we have the security appliances. We're going to quick grab the 5505 firewall, fast forward time so that can boot up, and just doing a really kind of a basic tour of what kind of things we're going to see on this. So when we're on the ASA, if we just do an enable, there's no password on it by default. So we'll just hit enter there. And I just want to do a quick show run so we can see kind of what's configured out of the box on these. One of the first things that you notice is, like I said before, we're running ASA. It's not iOS, but they operate almost identical. The interfaces are a little bit different. On the iOS side, 100 meg port referred to as fast Ethernet. With the ASA, it's just Ethernet. This firewall actually comes configured as a layer 2 port that's a member of a VLAN. With the ASAs, all of our configurations that we're going to make as far as IP addresses and the different ACLs that we're going to make will all incorporate the VLAN interfaces. So as we scroll down a little bit farther, we can see there's another VLAN that was already created. Its name is inside, which would be our LAN hosts. Outside, which is that VLAN we just previously saw, would be our WAN side of things. And they have different security levels. A security level is basically how much trust are you putting onto an interface. You can always move from a higher security level to a lower security level, but you should never be able to go backwards without explicitly allowing it with a firewall rule. So what that means is anything coming in from our outside, so from the internet, should not be able to access our inside. A few other things here, DHCP is enabled on the inside, so this should help facilitate when we want to set up a firewall. We could hook up a laptop to it, get a DHCP address and go through the web configuration, or they have what's called the ASDM, a Java-based applet. We're going to do things through the command line and a little bit through the web as well. Now in Packet Tracer, the web interface for configuring the firewall is actually not present. So we're going to get some good experience doing command line things. Let's take a look at a couple more things here. I wanted to do a show version. And this shows us our serial number of the firewall, which key we've used, as well as what our license is. If you wanted to see more specifically what you have unlocked on it, you can do a show activation-key. This tells you the exact limitations you would have because of your license. So as we can see here again, right, I'm limited to 10 inside hosts. I can create up to 3 VLANs. I can have 10 other VPN peers, 25 totals. Sometimes they limit you on the cryptography you can use, but it's good to kind of be aware of what's on there and how we can start to check that out. So I think that's going to wrap up this video. I just wanted to give you an introduction to some of the kind of quirks with picking out a firewall, how Cisco and Juniper do it slightly differently, and then show you the first look at how we get into a firewall and start to figure out what it's capable of.